Hello, this is Jeff Offit. I'm in the computer science department at George Mason and a member of the CS for All team. I'm stepping in to discuss programming and coding. So, programmable electronic systems seems like they're everywhere. Thermostats, ovens, alarms, sprinkler systems, robotic vacuums, even toasters are programmable. So we often say programming, but we're really configuring or setting some behavior in these devices, actually by modifying software that's embedded inside the devices. Programming and coding is different, as the definitions indicate. It's important that to recognize all of these take computational thinking, but we actually need some CS education to uh, to apply coding and programming in general, and that requires some level of specialized study. Programming is broader; it involves more human actions. It's preparing to code and it's evaluating the code, whereas coding uses specific programming languages that computers can understand. So, yeah, this is the confusing and the frustrating part. We don't use these words consistently. And in fact, as a computer scientist, the common definitions that we've put into the module, they actually confuse me because that's not how we separate coding and programming. Uh, but we're not asking you to be computer scientists. We're not asking your students to be computer scientists. Computer scientists are the kind of people who spend a lot of time coding, who probably enjoy coding and enjoy what is most people call nerdy human humor, like in my coffee cup here. So to close this out, uh, the type of programming language actually matters. It matters a lot. Computer scientists learn text-based programming languages in high school and college, and languages like Java, Python is what is most widely used in industry. They're hard to learn. They take a fair amount of study and they're very hard to master, but they're very general, they're very robust. You can do a lot with them. At the other end is what are called end user languages, which are languages that are designed for all users to learn and use with minimal effort, and they're limited. They're limited usually to one single application, and the intent is that you shouldn't have to study a lot to learn how to use those. In the middle is a block-based visual language. So a block-based video language is what we suggest elementary school kids use. And specifically, Scratch was designed for kids to learn so that the learning was less than the text-based language, but they can do more than it's more general purpose than an end user language. And Scratch Junior was then a modification of Scratch designed for younger children. So for the rest of this module, we will be focusing on Scratch and Scratch Junior as examples of visual languages.